Smitty here. I am trying something new tonight. I am on a laptop in a hotel room. You can all see my very exciting hotel room here in Seattle, lovely Seattle, Washington. I am on a business trip and back in my hotel room a little early. It's about 6:45 right now on the Tuesday night, and I don't really have any other plans tonight. So I thought I'd do a little bit more work on the DarkNet badge. I'm on a laptop. I've only got one screen, so it's a very small screen, which means I don't have the multiple screens to be able to watch what's going on. For example, the chat room. So I'm not even going to bother posting the link to this one. If people happen to see that I'm streaming live, then they'll see it. But I'm not going to advertise that I'm here because I won't be able to actually participate in the chat room tonight. So instead, I'm just going to be working on the layout. I've got a bunch of components. Also, my UI is going to be a little bit harder to follow. But let me make sure that's working. Oops. Forgive me, this is going to go a little weird. Yep, okay, it's working. So I've got all the components on the board, but that they're obviously not placed the way I want them to be placed. So we're going to have to spend some time kind of laying things out and getting them in the right spots. The primary concerns are that we are going to want to put buttons on the top layer. We're going to want to have a screen, the LCD screen, which is not that one. Where is it? Come on. There should be a 1x4 header. There it is. OLED display. So we're going to need to draw a box around that. And we're going to need that to be kind of near the push buttons. This year's badge, when you're looking at it, when the person is wearing it and you're looking at it here, the display is on top and then the buttons are beneath it, but that made it very awkward when the user grabbed the thing and held it up like this. Now the buttons were on top and the display was on bottom. So I want it to be oriented correctly when you're holding it like this. So the display will be on top and the buttons on the bottom here, but when it goes back down, so the display is going to be on the bottom and the buttons on top of them. So what I want to do, let's see here. Okay, well first off, I am going to get rid of these lines because those are not, okay, just delete. So these lines were the, I am also using a trackpad, trackpad instead of the trackball. Which is making this a little bit harder to deal with. Hey, come on. Fine, zoom in. Now, go. Okay, zoom is awfully aggressive. Good to know. So yeah, then there's also going to be the question about whether certain things go on the top or the bottom. I want to leave a lot of space on the bottom of the board for the battery, but there are other things that we can put on the bottom, like the STM32. Although, sorry, I keep telling myself that this is just a development board. I'm not going to try and make this one like a badge, so never mind. Forget I said anything. We're going to orient it like a just a normal like circuit board. It's not going to be a badge. Okay, well, let's go place the big items. I am going to want to figure out how those buttons are numbered. Nope, those are the buttons. What the heck? You can tell I'm not used to this user interface on the laptop. Okay, so it goes 1, 2, 3, 4, down. 1, 2, 3, 4, then 5, 6, 7, 8, then 9, 10, 11, 12. 7, 8. Except that 9 is reset. Oh, that's annoying. Forget it. Okay. There it is. All right. So trying to figure out where I want to start making a board. Kind of in the middle of everything, aren't I? Right. I'll just start it here and then we'll go from there. Why do I have... So this is also not my normal KiCad setup. Oy, okay. Well, I usually use a dot grid, not a not a line grid, but I suspect I will survive. What in the hell? Oh, you're in millimeters, aren't you? Getting back to inches. Yeah. I am not used to this UI. Why are those purple? This is not what I'm expecting. Okay. And unfortunately, I do not have I do not have the badge in my hand, last year's badge, or I guess this year's badge, to compare against. So I'm just kind of swagging some of these distances. Okay. And then 9 is reset. I'll put 10. Those are awfully close. You may want to move those a little bit. 13. Where'd 13 go? Where's 13? Do we not have a 13? Why don't we have a 13? Oh, there it is. So apparently I got confused on which one is reset. Okay. So those are our push buttons. Here, turn off. Turn off the values. Okay. All right. That is, of course. I don't have the dimensions of that right now, so that's going to have to be good enough for now. Oh, those need to be spread out more because I need to put the text underneath them. And the LEDs underneath them. So I'll just arbitrarily space them out like that. Already there. Okay. So let's move some LEDs under there. What are the numbers of the LEDs? So we'll do 1, 2, 3, and 4 for the DCD, and actually no. Doesn't matter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So we'll just have DN underneath SWN. Keep things simple. What? Why aren't you moving? Okay. I wonder if this is a different version of KiCad and I'm not just not used to it. Work machine. Okay. So first up, what the heck? Why? I don't know how much I'm going to be able to get done tonight. We'll find out. So F is flip, and we'll put a component on the other side of the board. Purposes, I'm going to put these up here. 13, 14, 15, 16. Well, oh no, these are going to be much easier to do this way. Okay, these are going to be off to the side. Where are the resistors? The resistors for the LEDs are in columns. Okay. what are the resistor numbers? R1, 2, 3, and 4. That makes it easy. So R1, move you to the top of the column. Oops, let's rotate you. Nope, I don't want to flip, I want to rotate. 1, 2, rotate. Oops. Skip that one. So these are the current limiting LEDs, or current limiting resistors for the various different LEDs. And you'll notice over here, I can't point with my finger, one resistor serves all 4 LEDs in a column. And we did these as, you know, D1, D2, D3, D4, and these are D1, D2, D3, D4, so I got one resistor in the column serving that entire column. And then, let's see here. I kind of want to find another way of doing those LEDs there. On the final design, they are, it goes like D, C, D, N on either side of the display. That's the same one, right? Yeah. Okay. Okay. Let's put those to, what are they? R7 and R8. So R7 and R8 are pull-ups for the I2C bus. So I'm going to put these up here. Oops. Space. Okay. Let's do the infrared transmitter. Do I want it hanging off the side? I think I want it hanging off the side. So that's how we're going to balance out the LEDs on the other side. So I want my keyboard roughly centered, but I've got these DCDN LEDs over on the right hand side. I'm going to balance them out by having the other stuff on that side. And these are just rough placements right now. This is not going to be finals. So where are they? R5 and R6. Where are... Oh, hey, look at that. Right there. Wow. When scrolling goes awry. So I actually want these to be near the edge of the board. And I want all three of those in a line. That's backwards, haha. So the status LED. So the infrared transmitter and receiver need to be in the correct orientation relative to each other. I don't care about the status LED being in the correct orientation. But I do want the transmitter and receiver in the correct orientation, and I believe that's how it is with, if this were the edge, the bottom edge of the previous boards, it's infrared transmitter, infrared receiver, and then the status LED, which is just a green LED. Okay, and so these are the current limiters for those. Got a radio module. We've got the microcontroller. All right. Here somewhere. Somewhere, this T-link here somewhere, something like that. Hey. Ish. And then center all of that. More to the center of the sheet. Okay. What I'm doing is I can't point with my finger. I'm looking at where these components that I lined up on the grid, where they landed. Make sure they landed in good spots. Okay. So is there anything else I'm going to be doing along this edge of the board? I don't think so. In fact, I'm kind of debating putting this stuff up here and then putting the micro on the other side of it over there. Yeah. So plenty of space there. Okay, that's a little bit nicer. What? Oh, no, nope, knock that off. Okay. Rotate. Where am I going to call the edge of the board? So as you may have noticed, that laying out a circuit board is a lot of trial and error. It's kind of like laying out a puzzle, except that there's no right answer. With puzzles, there's usually a right answer. In this case, it's oh, let me try this over here. No, let me try it over there. Let me try this. Let me do this. Oh, that kind of sucks. Or I like that better, but whatever. You're going to go back and forth and change things a lot. And don't be afraid to. That's okay. Well, let me put it this way. I'm not afraid to. I do it all the time. It's, just kind of part of the process to try something and see how it works out for you. And if it doesn't, then you try something else. And that's okay. That is all right. I do not want to put any of these components on the bottom of the board. I'm going to keep everything on the top. Well, with the exception of those LEDs. Now, the RF module does need to be on an outside edge. And that little 7 is the antenna. Excuse me. Do I want it along the top? I'm going to lay out everything else first, because that is surface mount. If I need to, I can put it underneath the display, because that's where it is on the other boards. In fact, you know what? I am going to do it there, because it's an RF component, which is going to matter a lot. The layout of like where things are and the shape of the traces and things like that are going to matter a fair bit. So I do want that to look like, except the fact that our displays are going to be at the bottom. Okay, I'm setting this aside for now. I don't want to do it right now. Put it off to the side. I do, however, want, I do, however, want a USB connector up at the top. Okay. Then USB goes into power, goes into the voltage regulator. Actually, first it's going to go into some capacitors. So, where are the capacitors? C9 and C10. There's C10, that's a biggie. That's the output. And that's going to go to our power plane. Where does C9 live? C9 right there. Okay. So that's the input, that's the regulator, that's the output. Okay. Okay. Let's place our micro. I want the micro somewhat centralized. And I want it to cross over as few lines as possible. I think the original orientation is probably as few lines as possible. But I'm going to need to give it some space, because we've got some crystals here that are going to have to land. And then I got some decoupling caps in there as well that need to be put close to the components. 8 megahertz has its own coupling caps. That one, however, does not. So that goes there. C2. C1. Oops. Ba-ba-bum-bum. Okay, so 3.3 volt. We'll just put that right on the output. Okay. Reset button near the edge. So we'll call that the outside edge. Also put that on the outside edge. So where are boot 1 and boot 2s? So that's one of them. Oh, really? On complete opposite ends of the chip? Okay. That's fine. Decoupling caps. So C5, let's go make sure. 3, 4, 5, and 6. 3, 4, and 5 are the 0.1s, and 6 is the 4.7. So we need a 0.1 and a 4.7 on the 3s, which are up here. So we'll go ahead and do that one there. And I think that one goes there. Then we'll do 3 down here. And 4 over here. And then, if I remember correctly, the 0.01 on the analog pins, analog power pins. Yeah. What's more important, keeping the analog power bypassed or keeping the parasitic capacitance of my crystals down? So the longer the leads between your crystals and your chip, the more capacitance there's going to be, the parasitic capacitance, just in the wires. And you want to keep that down as much as possible. I think I would rather move these out of the way and move these closer. Is that gives me plenty of space on the board to do other things. Why are those 2 middle pins not connected to anything? That's not good. This is just for spacing. Nope, too far apart. There we go. And then we will move you down here, which means the antenna is going to be on the bottom side of the board, which means I'm going to do that. Okay. So, very rough approximation. That is what my dev board is going to look like. Infrared transmitter and receivers are over here. My T9 keyboard, plus the backlit LEDs, plus the DCDN LEDs, plus the OLED display, which that might be encroaching on. Battery backup for RTC, we may not need that. Well, I know we probably don't need it, but It's there if we want it. USB. Alright. Let's go. Where is it? Edge cuts. Whoops. Let's go draw an outer edge to this board. Okay. So the LEDs can hang off the edge there. That gives me space to make an antenna, which will kind of hang off like that. Now I gotta start making sure I can lay out all the traces. What do you think? How's that look? You typically want to lay out all the components like this and look at the rat's nest. So all of these gray lines between all the components are the rat's nest. They tell you that pad needs to connect to that pad. It typically only does like the nearest pad as opposed to all the pads that it needs to talk to, because a lot of these are ground, for example. And rather than saying, well, this pin needs to connect to all of these other bajillion pins that are all ground, it just finds the nearest pin that's also ground and says you need to draw a line from here to there, assuming that you're going to want to keep your traces as short as possible. Now, ground is, of course, a bad example because I am about to draw what's called a ground plane. So I want this on layer selection, adhesive, paste, silk, mask, drawings, comments. What? Where's the copper layer? You're joking. Non-copper zones. What? No. What do you mean non-copper zones? Add fill zones. Add keep out areas. Oh, because I was drawing on edge zones. Okay. There. Okay. So I'm going to go ahead and do back copper. I'm going to make it part of the ground net. And all that's fine for now. So, and then I draw a, I'm going to draw a rectangle around the entire board. And what this is going to do is that it's going to make any area that is not another trace is going to make it a ground plane. Now, the way you get it to actually fill a ground plane, this is another thing that Eagle does better, is that you have it run a design rule check. And it's going to spit out all kinds of, oh my gosh, this pin is not connected to this pin kind of message. And that's fine. But we don't have any problems, so that's good. Design rule check is basically, you can program the thing to say, you know, these pins, or no pads can be closer than this amount of distance. You have to have this much distance between each of the traces, those kinds of things. Those are the design rules. And the DRC goes through and looks at your board and sees if there are any flaws in the design. Okay, so I told it to view it as a solid plane, and the bottom layer is currently a solid chunk of copper. But look carefully, you'll notice that these pins, where they are meant to connect to ground, now have these little diagonals off. The pad is connected to the plane. Those are called thermals because they are small small amounts of thermal mass between the pad that you're going to be soldering to and the copper plane, which will suck away as much of the heat as possible. It's still a good electrical connection, but it is a thermally isolated-ish connection that makes it a lot easier to solder to the pad. If this were just a solid, the pad were connected directly to this ground plane with a solid copper connection, and there weren't those little gaps in there, then you would have to put a lot of heat into that pad to get it to flow, and you would end up heating up the copper area around it, and that can cause damage to your board. So you only ever want to do you only want to do solid fills and solid connections to your pads where you know you really need it. Usually, like in RF applications, you want it there. But we're not doing anything that's going to be that critical. So thermals are fine, and it makes it a heck of a lot easier to solder. So yeah, you'll notice that a bunch of these have the thermals to the ground plane. So all of the rat's nests that were connecting to ground should no longer be connecting to ground. Although there are still rat's nests to ground. Why? I don't know why. Yeah, there's still a rat's nest line there. Not entirely sure why. I'm going to stop here because I've got something else I need to go run off to. But hopefully this gives you a little bit of an idea of kind of how to do a first swag at circuit board layout. And just kind of rough placing where all the components are going to go, making sure that things fit, kind of figuring out how large your board's going to be. I also laid out a ground plane, but that's not really part of the normal fit. And then we're going to go in and do like keep out areas here, which tell it this is, do not do a ground plane here. And I'm going to put a keep out area underneath the part of the wireless module where we're going to be connecting the antenna, because you can't have the antenna is going to be a trace on the board, but you can't have a ground plane underneath it because that will affect the antenna. The antenna needs to be free and clear from nearby stuff. So I'm going to put a keep out area down here and stuff like that. So anyway, that's what we've done. We've got a lot more work to do. Obviously, I need to make sure that these layouts are reasonable. And they're going to be, not too hard. And then I've got to actually start laying out traces, connecting everything up. Some of them are going to be pretty easy, like these buttons and LEDs will be pretty easy to connect up because they're all just straight lines connecting things. But getting in and out of that chip is going to be a pain. We're gonna, the whole point of this rough layout is to minimize the length of traces, the number of traces, and the complexity of those traces. I would much rather have 4 traces going straight up, and I will rearrange things if I have to make those traces short and straight, as opposed to having like traces that need to cross, right? Because then one of them either needs to go all the way around the other one, or you use vias and go underneath it, travel to the bottom layer and then go back up to the top layer, things like that. But I try to avoid those as much as possible. So the goal is to lay things out so that you don't have to do as many of those. Every once in a while you run into something that you can't avoid, but we're going to try to avoid as many as we can. I'm also seeing a bunch of pins that don't have rat's nests, like those USB connectors and the ST link, so I got to go back to my schematic and make sure that those are connected appropriately. I think I may have screwed that up. So anyway, that's it for now. I am going to come back maybe some other night this week. Maybe not, I don't know. We're going to see how my nights play out while I'm up here. But hopefully this worked out with the laptop and the smaller screen and the little laptop camera there and the iPhone headset. Hopefully this worked out, and yeah, anyway, thanks for watching. Go ahead and subscribe if you want. Hit me up on Twitter. I am at Smitty Halibut, SmittyHalibut on Twitter, which is the same handle that I use on YouTube. Ask me some questions, throw some comments out there, whatever you want. Let me know what you're thinking, what you're working on. Tell me what you're doing. Ask me, tell me I'm doing stuff wrong here, whatever. I don't care, but I just would love to hear from you. So anyway, thank you very much, and we'll catch you next time on Smitty's Working on Something. And it just dawned on me that I do not have a hotkey to to stop the broadcast system, OBS. So you get the woo, infinite mirrors, woohoo! All right, thanks everybody. See you next time. Wait, what? No, stop streaming.